Right, hello everyone. In this video we'll be looking at last year's June paper 2, question 8. So we're actually given two diagrams in this question. First diagram refers to 8.1, second diagram to 8.2. So let's look at 8.1. We're given a circle, the centre at O. We have K, T and L along the edges. We have M on the KL line, and we have S on the outside. We're given a couple of angle values. T1 or STK is 36 degrees, and K2 or OKL is 18 degrees. Right, so our very first question is, with reasons, determine the size of angle T2. Right, so this is easiest of a lot. T2 is equal to 90 degrees minus 36 degrees. Why do I say that? Because tans are perpendicular to rads. Sorry, I forgot to mention, but the paper mentions that ST is a tangent. Alright, so we have this radius here and a tangent. They're always going to be perpendicular. So T1 plus 2 should be 90 degrees. That's how we get to this. Alright, that's an easy one. What about 8.1.1b? Ask us to find L right here. So let me put in this value now that we know it. 54 degrees. Great. So something you might notice here, so we have a chord, K to T, and we have a tangent. Touches this chord as well. In other words, we can just say right away that angle L is 36 degrees Y, the tan chord theorem. As in, we know this is going to be equal right there. Okay, and now in part C of this question, we are asked to find KOT, as in that angle. Now, there's at least two ways to do this. There's the quick one, which is like so. We have an angle at the center of our circle. We also have an angle at the circumference. So right away we can say angle made by those 2 points also goes there. So angle at center circle is 2 times angle at circumference. What's double of 36? It should be 72 degrees. Cool. So that's the quick way. The ultimate way, you want to give yourself, actually doesn't take much longer. You can say that angle KOT is 180 degrees minus OKT minus T2. Why is that? That is the sum of the interior angles of a triangle. Right, we're looking at this triangle here. OKT of that right, let me first do angle OKT, which should be the same thing as angle T2. Why is that? It's angles opposite equal radii, so that's 54 degrees. Right, so this one's slightly longer because you have to prove another thing first, but to be fair, that means we found this is, right, it's 54 minus 18. That's somewhat useful. Okay, cool, that's all we need for 8.1.1. I'm going to pause, quickly erase, we'll go to 8.1.2. Right, so 8.1.2 asks us to prove that Km is equal to ML, as in that M is the midpoint of KL. Again, there's two ways to do this. Slightly quicker way, slightly longer way. Let's do the quicker way first. So angle KMO, as in that angle right there, is 180 degrees, minus 18 degrees, minus 72 degrees. Why? That's interior angles triangle. Sum to 180 degrees. And if you work that out, you should get 90. Great. So we know that this is a right angle. And then right away, if we know our rules well enough, we can just immediately say that those two lines are equal. Why? It's line from center circle perpendicular to chord. It's the inverse of the line from center circle to midpoint chord is perpendicular. Right, so that's the quicker way. The slightly longer way is to say that angle OKT is 54 degrees. We've proven that above. So we just say proven, don't worry about it. And angle K1 should be 54 minus 18. It's 36 degrees. Therefore, angle TMK, that one there, should be equal to 180 degrees minus 36 degrees minus 54 degrees. You can see how this is going to be the same thing, right? So that's the sum of interior angles of a triangle, 90 degrees. Therefore, we can say that Km is equal to ML, line from center circle to chord. Right. Same basic idea, just looking at two different sides of this. By the way, due to things like vertically opposite angles, that also proves that this whole thing just makes a nice little 490 degrees in one. Alright, but that's all we're doing with that half. Let's now go on to 8.2. Will I have enough space? It's fine, it's fine. So we're looking at this diagram here. What we're told is, there's this triangle. A, B, and C are all points on RDS, such that AB is parallel to DC, and, this is important, RB to BS is equal to 5 to 3, right? So we're given that the ratio of those sides right there. Additionally, we are told that DC is 20 units and CS is 12 units. Great. So now prove that BC, this line here, is parallel to AD. Right, so we want to prove this parallel. Okay, the easiest way is to do it like so. DC over CS. We're given these values, so it's nice and easy. Right, 8, 5 over 3. So DC over CS is equal to RB over BS. Okay, immediately that should be ringing some bells in your head. It means that this line is parallel to that line, right? The law we're referencing here is converse line parallel to one side triangle. Alternatively, you can list the law as sides in same proportion. I recommend against it though, because converse line parallel one side triangle, if you remember that rule, you're more likely to spot it, just because of the wording there. Anyway, either way, because BC is parallel to DR, it must also be parallel to AD, right? Okay. So that was a fairly easy one. I'm going to have to pause, erase, and we'll look at 8.2.2. So in question 8.2.2, they first give us RD, that whole line there, is 48 units. Very nice of them. Given that, they want us to calculate the ratio of AD to AB. Right. So we want this ratio, AD to AB. How we ought to start, I think, is AR divided by AD should be exactly the same ratio as RB over BS. The reason for that, line parallel one side triangle. Alright. Now, we also know that AR over AD is equal to RB, BS is equal to 5 over 3, right? That was proven above. Great. And we know that DR is 48, right? That's a given. So, AR is 48 minus AD. Okay, that part should be fairly clear. So, 48 minus AD all over AD should be 5 over 3. Right, using this bit here and this bit here. Alright, so let's just rearrange a bit. 48 minus AD is 5 AD over 3. What should we do? yeah, sorry. If you just rearrange, do some maths, your final answer should be that 144 is equal to 6 AD. Therefore, 18 is AD. But we're not looking for AD, we're looking for this ratio here. So we just want to find AB, right? AB is a part where you ought to see, actually, we've known AB for a while now, right? This here is a parallelogram. So this side should be the same as that side. Sorry, not 20 degrees, just 20. That's the up sides of a palm. Great. Now we can just say that AD to AB is the same as 18 to 20. We can simplify that. 9 is to 10. Okay. Biggest thing here was just finding out what AD was, but we had all the steps already planned out for us. And that is question 8 of paper 2 last year, June. Next video, we'll look at question 9. Yeah, question 9.